Hello, my name's Jeff and I like building tube amps. This one here is an all-tube 5-watt amp, single-ended. It's got reverb, tremolo. It's housed in this beautiful Philco cabinet that came from an old Philco radio. And in addition to the tremolo and reverb, it's got a 3-position attenuator knob. So you can go from 5 watts down to 1 watt and then further down to about 1/4 watt. So circuit-wise, this amp is kind of like a 50s Princeton with a 60s Vibro-Champ tremolo and a transformerless reverb circuit that is not really like anything in a Fender, but you see them in some other amps, trainers, and amp pegs and a few others. Let me play a little bit for you and then we can talk more about the circuit. I actually picked this cabinet up a couple of years ago and I built a different amp inside of it, but I never really quite finished it. One of the things that kept tripping me up was how I was going to label the knobs. And I've played around with building a faceplate out of metal and engraved metal to go in front of it, but I just really didn't like the look of that. And then recently I hit upon the idea of taking these knobs, which are fairly common mostly for guitar pedals, and they have these little silver discs on them. I found you could pop those off, and I just laser cut and engraved a little circle to replace them, and that would be how we'd label the knobs. So I think that came out nicely, and that sort of made it all complete for me. So I'm a cheapskate, and I tend to build with a lot of repurposed parts or, inexpensive parts. In this case, the transformers in this amp are new, but they're actually isolation transformers. They're usually used to isolate your circuit from the wall voltage, and these are made to put out the same voltage that goes in. Now you can wire them so that they're either 120 or 240, but it's also fairly well known that you can wire them in reverse and have 120 come in and 240 come out. Hence, that's how you get your high voltage. In reality, it's closer to 200 volts instead of 240 once it's loaded down, but it works pretty well. Once you rectify it, you end up with about 250 volts on your output tubes, which is low for a lot of amps. Most Fender amps are in the 300, 350. You get up to 400s in the Princeton Reverb and Deluxe Reverb, but it'll run a 6v6 at 250 just fine. The tube lineup in this amp is just a little different than you normally see as well. The power tube is a 12v6 as opposed to a 6v6. Now really it's the same tube, but they use a 12-volt heater instead of a 6-volt. I've got a 12-volt transformer supplying all the heater voltages in this amp. Now the preamp tubes in this amp are Russian tubes, 6N2Ps. Now those are pretty much an equivalent of a 12AX7. They're functionally equivalent. The heaters are wired slightly differently. A 12AX7 can be run at either 12 volts or 6 volts. These 6 N2Ps can only run at 6 volts. Now, since I'm running 2 of them, I actually have them running in series, so those 2 together make up the 12 volts. I did this partly because I've got a lot of these tubes laying around, and partly because I wanted to see if it would work, and it works out just fine. The Reverb is a 12AT7, and it's running a transformerless circuit. So normally on a Fender amp, you'd see a 12AT7 running in parallel and pushing a transformer that puts out about 8 ohms, and that runs that drives the reverb tank. In a transformerless circuit, you're running a tube at a little higher current. This runs about 8 or so milliamps, and that is what's driving the reverb tank. This is I think a 600 or 800 ohm tank. So I'm using one side of the 12AT7 to drive the tank, the other side to recover it, and it works pretty well. The tremolo circuit is lifted pretty much from a Vibro-Champ. If there's a few changes, I'm using a dual pot to get a little more range in the tremolo speed, and also there's a switch on the back that will add in another capacitor, which slows that range down even more. So there's 2 ranges, and they're a little bit wider than you would normally see. So for me, I do most of my playing by myself in my office and with the family in the next room, so they don't like it super loud. And a 5-watt amp is actually really loud, so that's why I put the attenuator in here. It's the simplest of all attenuators. There's just an L pad circuit, and actually 2 separate ones. The knob will switch in between. An L pad circuit is just two resistors that go in series and in parallel with the speaker output, and it absorbs some of the sound, so that what reaches the speaker ends up being less signal than what was coming out of the output tubes. The common complaint with these is that you're going to lose some high end from it, and that is true. But that's what I use the tone knob for. So typically when I'm using the attenuator, I'm cranking the treble up a little bit. To me, it's fine. It's a fine trade-off. It's the cheapest and easiest attenuator, and for this purpose, I think works fine. Just so you can hear the relative volume difference in the attenuation levels. Here's just a couple chords played at each setting, and you can kind of see how much the volume drops off from 5 watts to 1 watt to 1/4 watt. The output transformer on this amp is actually just a cheap Chinese transformer that I got on Amazon. So I've got a handful of 5-watt transformers, and I tried them all in this amp, and this is the one that I like the best. It felt like it had the most bass response and just the widest range of sound. So it's what I'm going with. Overall, I'm super happy with the way this amp turned out. I think it looks great. I think it's unique. I mean, obviously this is not an amp to go take to your local bar to gig or to take on tour, but for what its intended purpose is, which is a small practice amp basically to sit in your living room, your office, your bedroom, and give you a variety of sounds at a variety of levels. I think it's I think it's great.